Hey there, and welcome. Today we're going to tackle one of the trickiest parts of C programming, and that's the whole relationship between pointers and arrays. We're going to look at it through the kinds of questions that always seem to pop up on exams. So if this topic has ever made you scratch your head, you are about to have that aha moment.
All right, let's just jump right in with a puzzle. Imagine your professor puts this code up on the screen. 1 square bracket R. Now your first gut reaction is probably, that's a syntax error. No way that works. But what if I told you it compiles just fine, and it actually runs? The answer to this little riddle reveals something really fundamental about how C actually works under the hood.
The key to solving that weird puzzle, and really this whole topic, comes down to one single golden rule. You have to remember this. In C, an array's name isn't really the array itself. It's just a pointer to the very first element in that array.
If you can really get what this slide is showing, you are honestly halfway there. When the C compiler sees the normal array brackets like RRI, it doesn't even think of it that way. It immediately translates it into pointer notation, RR plus I. So they're not just, similar. To the compiler, they are the exact same thing, just two different ways of writing the same instruction to get to a spot in memory.
So, this automatic switcheroo has a name. It's called array decay. The name of the array, R, just sort of decays into a pointer. And that is exactly why our crazy puzzle from the beginning works. Think about it. Since R sub 1 is really just secret code for R plus 1, and we all know that addition doesn't care about order, R plus 1 is also totally legal. And what's the array notation for R plus 1? Yep, you got it. 1 sub R. So the code prints 7. Wild, right?
Okay, so if an array name is just a pointer, that must mean we can do math with it, right? And we can. This is called pointer arithmetic, and really understanding how it works is absolutely crucial if you want to avoid those common mistakes on your exams.
And here it is, the big idea. Pointer math is smart. It knows what kind of data it's pointing to. So when you add 1 to an integer pointer, C knows you don't want to land halfway through the number. It automatically moves the address forward by the full size of an integer, usually 4 bytes, so you land perfectly at the start of the very next element.
Let's just picture this for a second. The pointer P starts out aimed at the first element. When we run P++, it doesn't just nudge forward a tiny bit. Nope. It takes a full leap, jumping directly from the beginning of R0 right to the beginning of R1. It's all because it knows the size of what it's pointing at.
Okay, time for a quick pop quiz to see if you're with me. We've got a pointer, P, pointing to the start of this array. So, what value are we going to get when we ask for star P plus 2?
The answer is 30. It's pretty straightforward when you think about it. P starts at the first element. P plus 1 points to the second one, so P plus 2 points to the third one. Then we just use that little asterisk to dereference it, to look at the value inside, which is 30. See? Simple as that.
Now this whole pointer thing, it isn't just for reading data. Let's see how we can use this power to reach directly into an array and actually change what's inside.
So what is actually happening here? Well, we use P plus 1 to find the memory address of the second element. Then that asterisk dereferences it. It's like opening the box at that address. And once it's open, we just stick a new value in there, 50.
And boom! This shows you the kind of direct control a pointer gives you. We didn't say array 1 equals 50. We used a pointer to go straight to that spot in memory and change it forever. This is a really fundamental skill in C programming.
All right, let's step into the exam zone. This is where we look at those sneaky operator precedence questions that professors just love to put on tests. You got to pay super close attention here, because where you put a single plus plus sign can change absolutely everything.
So here we go. We've got the little star, the dereference operator, and the postfix increment, plus plus. The order that these things happen in is everything. What do you think happens first?
If you guessed that it prints 1, you are absolutely right. But the real question, the part you get points for, is understanding why. The secret here is that postfix plus plus. I want you to think of it as use the value, then change the pointer. So C first looks at star P, grabs the value it's pointing at, which is 1, and sends it off to be printed. It's only after that value is safely on its way that the plus plus kicks in and moves the pointer P to the next element.
Okay, round 2. Now we've switched it up. We're using the prefix increment operator. The plus plus is before the times P.
It seems like a tiny change, but trust me, it has a huge effect on what gets printed and what's left behind in the array.
And this time, the answer is 2. So let's break down exactly why, step by step.
See, with the prefix ++, things get evaluated right to left. So first C figures out star P, which gets the value 1. Then the ++ is applied directly to that value, changing the 1 into a 2. And it's this new, shiny value of 2 that gets sent to the print function. But what's really important is that the original value back in the array has now been permanently changed to 2.
Okay, deep breath. Let's pull this all together. If you can really lock in these next 4 concepts, I promise you'll be able to handle almost any pointer and array problem that comes your way on an exam.
These are your 4 pillars. First, burn that golden rule into your brain. Array brackets are just pointer math. Second, remember that pointer math is smart. It moves by the size of the element. Third, master the huge difference between star P++ and ++ star P. And finally, never forget that pointers give you that direct, powerful control over memory.
And that's a wrap on this explainer. You now have the core logic you need to really master pointers and arrays in C. But it leaves you with a bigger question to think about, one of style and performance. Now that you know they do the same thing, when should you actually choose the raw power of a pointer over the simple readability of an array? Keep experimenting, keep coding, and thanks for watching.